Here we'll take a look at some additional examples solving for z. Okay, here we have our z-score formula once again. Z equals x minus mu over sigma. And using mu, population mean of 30, and a population standard deviation of 3, we're going to solve for the following values of x. 28, 31, 40, 19, 26, and 34. So let's go ahead and do that. Okay, first we'll start with 28 and just tackle them in order, each one. Okay, so z is equal to, let's just fill that right in. We're going to use this formula every time. So z is equal to 28 minus 30 over 3. And to save room, I'm just going to write to the right here until I'm done with it, until I have it solved. Minus 2/3, or z equals negative 0.67. Okay, that's 28. Let's go to 31 now. Z equals 31 minus 30 over 3. And make sure that you figured out where all those pieces went and why. That's equal to 1/3, or z equals 0.33. Okay, our next one, an x of 40. Let's do this one together here. We're going to plug in an x of 40 there, so z equals 40 minus our mean of 30 divided by our standard deviation of 3. And this is equal to 10 over 3, or z equals 3.33. Okay, we are halfway done. Let's go ahead and tackle these last three in order. Here we have z equals 19, x of 19, minus 30 divided by 3. That gives us negative 11/3, or the z of negative 3.67. Here we have x of 26, z equals 26 minus 30 over 3, which is negative 4/3, or a z of negative 1.33. And then finally, we have an x of 34. So we have z equals 34 minus 30 over 3, or 4/3, which is equal to a z-score of 1.33. Okay, so we've solved for these 6 z-scores here. And let's go ahead and go through each of them and interpret them in terms of what z means, in terms of the standard deviation units. A score is away from the mean. So here, for example, starting with an x of 28. For an x of 28, that produces a z-score of negative 0.67, which means that a score of 28 is 0.67 standard deviations below the mean. A score of 31 is 0.33 standard deviations above the mean. And remember, it's above the mean because it's positive, whereas this value was below the mean because it's negative. Here, a score of 40, an x of 40 produces a z of 3.33. So that means an x of 40 is 3.33 standard deviations above the mean. Here, an x of 19 resulted in a z-score of 3.67. Negative, right? Negative z indicating that it's 3.67 standard deviations below the mean. The score of 26 produces a z of negative 1.33, so it is 1.33 standard deviations below the mean. And then finally, a score of 34 resulted in a z of 1.33, indicating that that score is 1.33 standard deviations above the mean. This concludes the example of solving for a variety of x's. I'm solving for z-scores for a variety of x's.